Hi. Now, you should already be familiar with the compound angle formulae, or as some people call it, the addition formulae. And what I want to show you in this tutorial is how we can build on these results and get what is called the double angle formulae. And we do this by letting b equal a. Okay, so we'll just put this in here, let b equal a. So for this first identity, the sine of a plus b is identical to sine a cos b plus sine b cos a, or you could have cos a sine b. It's not going to make any difference here. But for this identity, if we let b equal a, what we end up with is sine of a plus another a, because the b stands for an a. And a plus a is 2a. So we get sine of 2a. What is called a double angle. And so that's going to be identical to sine A, and this B is replaced with an A, so we get sine A cos A. Let's just write that in, sine A cos A. And then for this term here, where this B is, it's replaced with an A, so we get sine A cos A again. So plus sine A cos A. Now we've got two terms here, exactly the same, so we end up with the result that therefore sine 2a is identical to two lots of sine a cos a. So that's the first identity that I would encourage you to learn. Now if you forget these identities, you can always build them up from these results. So it is your understanding that really matters here. Okay, well, I'm not going to do the cos one at the moment because that's a bit more involved. But you might like to try this one. The tan of a plus b we know is tan a plus tan b all over 1 minus tan a tan b. By doing a similar thing like this, you should be able to work out what the tan of 2a is. So maybe you might like to just give that a try. Okay, so let's see what we get. So if we replace the b with an a, we're going to have tan of a plus a, which is the tan of 2a. So tan of 2a is identical to tan a plus another tan a. So in other words, we have two lots of tan a on the top. And then all of this is divided by 1 minus tan a times another tan a. Tan squared a, in other words. So on the bottom here we have 1 minus tan squared a. So it'd be good if you got that one. Okay, let's just highlight this. Now I said I was going to leave the cosine one to the end because it's a bit more involved. So you might like to again have a go at coming up with an identity or two, and that's a little hint. Okay, there are several identities that you can get for the cosine of 2a. Have a go, see what you come up with. Okay, well, let's see, how did you get on? Well, let's start with cos 2a then, where we replace the b with an a. Cos 2a is going to be identical then to cos a times another cos a, cos squared a in other words. Minus, and we've got sine a times another sine a, sine squared a. So, did you get that identity? Well, if you did, well done. But what we can do is we can go on and get more. And how can we do that? Well, we should know that sine squared of any angle, let's call it A, plus cosine squared of any angle, or cos squared plus sine squared of the same angle, doesn't matter which way around we have this, always comes to 1. And we can use this identity to change this result up here. Because for instance, sine squared a, let's just write it in, if we were to rearrange this, sine squared a would be identical to 1 minus cos squared a. And also, if we made cos squared a the subject, we'll just say also cos squared a would be identical to 1 minus sine squared a. So what we can do is we could put this result into our identity up here. So what we end up with is, if we replace the sine squared a with 1 minus cos squared a in here, you've got to be very careful with this one. Cos 2a would be identical to the cos squared a here, and then we've got minus, and then replacing sine squared a with 1 minus cos squared a. There's a couple of terms here, so you've got to be careful. You've got to put that in a bracket. So if we open up this bracket, if we expand it, multiply it out with the minus 1 that's here, what we end up with is that therefore cos 2a turns out to be cos squared a, and we've got minus minus here, cos squared a, making another plus cos squared a. So we end up with cos squared a plus cos squared a, which is 2 cos squared a. And then we have this minus 1. So we get this identity, this other version for cos 2a. An expression totally in terms of cosine. Now we can do a similar thing here again, only this time using cos squared a as 1 minus sine squared a, put it into the formula here. So we also have that cos 2a would be identical to, so in place of cos squared a, we've got 1 minus sine squared a, and then we've got the remaining minus sine squared a. So what do we end up with? We end up with cos 2a then being identical to 1 minus, and we've got 2 sine squared a there. So you've got to try and remember that one as well. But if you do forget these, I feel that it's most important that you understand where they came from, so you can drop back to these basic formulae. Okay, well, that brings us to the end now of how we prove these identities.